The moon is a harsh mistress with an airless surface racked by 2-week periods of scorching sunlight followed by the long night. But below its surface lies caverns and tunnels we might shelter in that are greater in scope than anything on Earth. Today we'll be examining the pros and cons of settling lava tubes on the moon and other places, along with asking what life inside one would be like for those early settlers. Lava tubes are natural underground tunnels formed by flowing lava under the surface of a planet or moon, or a larger asteroid for that matter. They are created when the surface of a lava flow cools and solidifies, while the lava beneath continues to flow. When the lava flow stops and drains away, it leaves behind a hollow tube. As best as we can tell, most lunar volcanic activity was between 3 to 4 billion years ago, but some activity was as recent as a billion years back. Normally, where Earth is considered normal anyway, such tubes would be long gone, but there is no continuing geological activity to shake them, nor wind or rain or flood to collapse them or fill them with sediment, nor organic processes inside to break them, as moss or tree roots can do to stone on Earth. And indeed on some planets, lava tubes might be the only place life could reside or begin, but that life might damage those tunnels and self-destruct their ecosystem in the process. This lack of destructive forces also means they can get very large, even compared to the ones we get on Earth where they can be wide enough to drive a truck down and miles long. We think some on the moon might be as much as 500 meters or 1,600 feet wide and tens of miles long. We can spot these by various entries where it's collapsed, called skylights, and the basic notion is that you find such a tunnel, dome over those skylights, and fill the lava tube with air. This can be a short-term base inside a small lava tube that really is just pressurized with oxygen, probably produced by taking oxide minerals and turning them into metals for use, and with oxygen as a waste byproduct. Or we could be looking at huge affairs with liners put in to help seal air and moisture in, and entire ecologies that we might transport to the moon. We'll discuss such options in a bit, but let's cover the basic advantages first. Lava tubes are of significant interest for lunar exploration and potential settlement for several reasons. Protection from radiation and micrometeorites. The moon's surface is bombarded with cosmic radiation and micrometeorites due to the lack of protective atmosphere like Earth's. Lava tubes, being underground, provide natural shielding against these hazards. In this regard, it's much easier to create pressurized environments as well, since you do not need to import or manufacture your wall and ceiling, and thick and redundant enough to survive radiation and micrometeors. Radiation will generally be very rough on most materials we would use for a dome, and thus limit service lifetime. Temperature stability. The moon experiences extreme temperature variations, ranging from very hot during the lunar day to extremely cold during the lunar night. Needless to say, temperatures ranging from colder than Antarctica to hotter than the Sahara are not optimal for human habitation. Lava tubes maintain a more constant temperature inside, which would be beneficial for human habitats and sensitive equipment, and which seriously cuts down on how much power you need for heating and cooling. Structural integrity. Lava tubes are believed to be structurally sound, providing a natural roof and walls that could support lunar bases. I think you'd want to shore them up if you plan to spend a lot of time in them. But the far lower gravity on the moon makes that easier too. So this would reduce the need for heavy construction materials to be transported from Earth or that need to be fabricated on the moon, since at the very least, you need less structural materials and don't need them on day one. Potential for water ice. Some lunar lava tubes, especially those in permanently shadowed regions near the poles, may contain water ice deposits. As we discussed in other episodes on lunar ISRU or in situ resource utilization, if we have ice, we not only have drinking water, but a lower energy way to produce oxygen, and even fuel production if it is in sufficient quantity. And unlike other scarce resources, we're not really worried about depleting the moon of ice if it helps us develop in space, since once you get out past the asteroid belt, there's an ocean of the stuff available for importation. Indeed, as we'll discuss next month in Colonizing Ganymede, there's more water on some of those outer system moons than in all of Earth's oceans. Ice inside a lava tube is also easier to extract and store without needing huge and sturdy surface tanks. In zero or low pressure environments, there's only a very narrow window of temperature a substance can be a liquid. It is essentially a state at which matter can no longer hold together on its own because it's vibrating too fast, but doesn't fall apart as a gas because some other gaseous materials around it are helping shove it together. Remove those and it turns into a gas, and in an airless environment like the moon, liquid water effectively cannot exist, just ice and steam. Next is scientific exploration. Lava tubes might contain geological and mineralogical treasures that could offer insights in the moon's history and evolution. They also make great base camps for extended exploration activities, as you could plausibly hole up inside one, maybe find ice for drinking and air, and with a lower temperature variation, potentially survive a lunar night without freezing or escape the intense sunlight of the lunar day. Speaking of that, natural habitats. Lava tubes could provide ready-made habitats, requiring only minimal alterations to make them habitable, which is more efficient than building structures from scratch. Much like caves in a mountain, lava tubes on the moon become safe places for those roaming the moon and logical forced bases in a given area. Given that gravity is very low there, you can still construct a surface base nearby, including a dome over the skylight and solar panels, while having easy access to large underground lava tubes. Even staircases hundreds of feet high on the moon would be easy climbs, so long as you're not doing them in a full spacesuit. In summary, lava tubes on the moon could provide natural, safe, and stable environments for future human explorers and settlers, reducing the need for extensive and heavy construction materials and offering protection from the harsh lunar environment. Now, back in our episode The Domes of Mars, we went over the pros and cons of domes versus underground facilities, and as we noted there, it isn't an either-or situation. You will have both, but the ratio will be very dependent on practical considerations, many of which we really don't know yet. Many of those disadvantages to underground living or advantages to surface life are essentially the same on the moon as Mars, but there are some vital differences, and one of those is that the day on Mars is basically the same as Earth's, just a hair longer. Not so on the moon where the day is a month long. 2 weeks of sunshine followed by 2 of darkness, which means living in a dome on the surface of the moon is not a close approximation of Earth conditions except for a little lower gravity like on Mars. We detailed those disadvantages more in that episode, but here's a summary of them, and in regard to lava tubes on the moon specifically, and there are also notable disadvantages and challenges. First is accessibility. Lava tubes may be located in regions that are difficult to access with current technology. We are not going to just land a spaceship in one. Indeed, that would be a rather bad idea for a number of reasons. Nor are you landing right next to it, unless dropping a spaceship on or next to it gives you immediate data on how stable that lava tube happens to be. So to get to one includes challenges in both landing as near these structures as circumstance allows and entering them safely. This is why we usually see them as a Phase 2 operation on the moon, not the place you land your first astronauts at to set up an alpha base. Which brings up structural stability. While lava tubes are generally stable, their structural integrity could vary. Some may have weak spots or be prone to collapse, especially under the stress of human activity or lunar quakes. Again, trying to access them or land near them might be all it takes to set them off. Limited natural light. Inside a lava tube there is no natural light, not even the 2 weeks on and 2 weeks off the surface gets, which would necessitate artificial lighting systems for both practical and psychological well-being of the inhabitants. It's a bit debatable if they'd be a better place to grow food at than a surface dome, since either one needs supplemental lighting. Though considerably more in a lava tube, and a plant can undergo low lighting, such as a protracted cloudy week, and rapidly bounce into growth when the lunar day begins again, so a dome probably wouldn't need more than a fraction the artificial lighting a lava tube needs. Isolation and confinement. Living in a lava tube would mean being in a confined, enclosed place for extended periods, which could have psychological effects on the inhabitants. This isolation could also make emergency evacuation or resupply more challenging, though I think the time in a cave is probably no more psychologically worrisome than time in a thin glass dome surrounded by a total lack of atmosphere. Communication challenges. Communicating with the surface, or Earth, might be more difficult from within a lava tube, requiring relay systems or other technological solutions. On the Earth side of the moon, Earth is there day and night, always more or less in the same place in the sky, varying depending on where on the moon you're at. Getting a signal there is pretty easy, whereas a lava tube might require many hundreds of feet of wire, if not entire miles. There's also environmental unknowns. We just don't know what they are like inside beyond educated guessing, as we have never probed one. The environment inside a lava tube could present unknown hazards, much as the sharp regolith on the moon surprised us during the Apollo era. There's also the question of not what they might have, but what they might turn out not to have, like sturdy sides and ceilings. And off our own moon, they are the sorts of places where we might find existing life on a planet or moon whose surface seemed otherwise barren. Resource availability. While some lava tubes might be located near potential resources like water ice or a good place to build a landing field, others may not be. This could necessitate long-distance travel on the lunar surface to transport resources, adding complexity and risk. I sat through a talk by my friend Pascal Lee last year where he was examining good landing sites based on where we might get water ice, and the moon is a place of sharp and steep features, so very often a rover wanting to navigate between two places might have to go miles out of the way just to get to a spot very nearby. It is easy to forget that the moon is huge, and traveling around on it is much harder than on Earth. I think we tend to assume after traveling huge distances to get there or to some planet like Mars we can just ignore those distances on the ground, but they are very difficult places to traverse even if you had a large supply of equipment and fuel to do it with, whereas we are likely to be very limited in that regard early on. Here on Earth, where moving is easier, we would never say a supply of ice 10 miles from where I wanted to build my home was easy access to water. Which takes us to technological and logistical challenges. Setting up a base inside a lava tube would require advanced technology and significant logistical planning. This includes the transport of materials, life support systems, and the development of infrastructure for energy, waste management, and habitat maintenance. In theory, an inflatable dome can simply be kicked out the side of your lander and inflated from tanks. There is also limited expansion potential. While huge in terms of any near or mid-term need, the size and shape of a lava tube might limit the potential for expanding a lunar base. Like caves on Earth, they are not big enough for truly impressive civilizations. This could be a significant constraint as the needs and numbers of inhabitants grow, though they could potentially dig more tunnels or simply spill onto the surface. Digging in low gravity can be easier. Lack of emergency exits. In case of an emergency, options for quick evacuation could be limited, especially if entrances and exits are few and far between. I think this is outweighed by the protective advantage they have, but it is very true that unless you're right by a skylight, in event of collapse, you've only got two directions to travel, at least one now blocked off. So while lunar lava tubes provide some natural advantages for establishing a lunar base, they also present a unique set of challenges that require careful consideration and advanced technological solutions. All that said, they remain very attractive as spots to set up shop, and many will be big enough for big communities, though the question would remain why you would want to build one there. Why live in a lava tube, and why build a base or settlement there? And I don't just mean why would you live in a lava tube as opposed to some random crater. To settle the solar system, you need a reason you might want to live somewhere as opposed to moving off Earth, and to some godforsaken rock as opposed to a nicely tailored O'Neill cylinder orbiting it. Economically, it probably means you're in the mining or refining trades, or build or maintain large power collectors, at least as the main lifeblood of the local economy. You could be anywhere in the galaxy doing just about anything, maybe even including a pirate base, and probably still find lots of shops, retail stores, restaurants, teachers, road crews, and excluding the pirate case, police. So let's take a visit to New Sudan, a lunar lava tube settlement founded principally from eastern Canada and New England, and it runs in a lava tube 30 miles long that winds its way around the eastern edge of the moon, where Earth is always visible, but on the horizon. New Sudan has something fairly rare in lava tubes, and that was deposits of gold, found in the year 2149, and before the year was out, claims were in place and several hundred tons of equipment dropped there in order to facilitate establishment. By the late 22nd century, it also had the largest tourist income of any principally underground settlement on the moon. The gardens of New Sudan are often loftily compared to the Hanging Gardens of Babylon, though mostly by their tourist bureau. At a population of 20,000, New Sudan is a long, skinny settlement 30 miles long and varying between half and a quarter of a mile wide, with an estimated 10 square miles of subsurface living area or 6,400 acres. In addition to its handful of skylights, which are now domed over, several artificial skylights have been added. These use a shifting filter to brighten and darken the dome and alter how much red or blue light is coming through to simulate time of day better. The sunset on the moon, incidentally, is not red, as there's no air producing that prism effect. Running down one side of the colony and about a mile to the side is a long field of solar collectors that help their refineries during daytime, with excess energy pumped into molten salt thermal wadis for nighttime usage. In tandem with a nuclear reactor, this helps power the night phase, where your daylight is simulated at closer to that experience on a cloudy day. New Sudan holds the interesting title of highest number of tanning beds and sunrooms per capita in the Guinness Book of Solar Records. Shade plants tend to be most popular for personal gardens on the moon, since they need less artificial lighting to keep them thriving in dark weeks. But mushroom gardens are also very popular, and often fed on nutrient mass from crops that can bloom well under just 2 weeks of bright sun, such as algae. Domed algae farms on the moon are rather common since they are a good way of creating topsoil from the existing regolith and ice, and various strains can be used to create feedstocks for plastics or fuels, and edible sources of protein too, for both humans and what limited livestock are adapting to the moon thus far. You can cycle up algae in domes when the sun rises and have a full supply for processing 2 weeks later, and use the same personnel for both operations, as well as getting the domed vats ready for their next round. The folks of New Sudan do the same for mineral extraction too, typically mining during the dark weeks, then doing their energy-intensive smelting and refining during the sunnier days when the solar farms are producing. There's talk of more microwave power satellites being placed in orbit to beam energy down to those in the dark weeks, and the settlement's mayor, Camille Cormier, did campaign this last election on helping raise capital for that project. The Cormier family is a trusted name in lunar circles, especially the lava tube communities, as the Cormier family is among the original 100 to first call the moon their home. Back then they were nestled in a smaller lava tube beneath the moon's powdery surface and were instrumental in prototyping both the algae mushroom farm cycle and lava tube mineral extraction. They were pioneers, part of the grand experiment to test the feasibility of extraterrestrial living. Their new home was a cylindrical habitat sealed within the ancient hollowed rock. The tube's entrance was a marvel of engineering, a dome of transparent aluminum allowing a panoramic view of the stark lunar landscape. Inside, Lunar Haven was a stark contrast to the barren outside. The interior was spacious, designed to mimic a comfortable Earth-like environment. It even had a small garden, where genetically modified plants thrived under artificial sunlight. Serena and Baptiste Cormier, along with their 2 children, Camille and Leonardo, adapted quickly to their new life. Their days were structured yet varied, filled with maintenance tasks, scientific research, and homeschooling, since even remote teachers from Earth had uncomfortable signal lag time. The family had to be self-sufficient, relying on their habitat's closed-loop life support systems for air, water, and food. One of the most significant challenges was a lack of natural sunlight and Earth's gravity. The Cormiers combated this with daily exercise routines and a special lighting system that simulated natural progression of day and night. This helped them maintain their circadian rhythms and kept the plants in their garden growing. But they knew that was an uphill fight, and they needed to create ecologies and agriculture more suited to their new home on Luna. They had access to a vast collection of entertainment and data though, albeit not without limitations from light lag and bandwidth constraints. Despite these comforts, life on the moon was not without its trials. The isolation was palpable. Communication with Earth were limited to video calls and messages with a delay, making them feel even more distant from their friends and relatives. However, they found solace in each other's company and the unique experience they shared within their family and a handful of those other early settlers living similar lives, and within instant communication range. For Camille and Leonardo, they learned about lunar geology right from their home, exploring different parts of the lava tube with their parents. These expeditions were the highlight of their week, donning their small spacesuits and venturing to unexplored sections. The most significant event for the Cormier family was when they discovered ice deposits in a remote location of the tube. This discovery was monumental as it promised a more sustainable water source for future lunar settlers. Over time, the Cormier family became a team, each member playing a vital role in the survival and success of their mission. They were among the first to celebrate the new lunar holidays, created new traditions, and even shared their experiences to those back on Earth by video, which indeed was one of their major sources of funding and endowment. Unfortunately, Leonardo's plans to be the first professor of lunar geology or selenology on Earth who was trained for it on the moon fell through when the terrestrial gravity proved too much for him, being used to only a sixth of what it is on Earth. He returned to the moon in 2148 rather depressed, but determined to continue his work, and was grateful when Camille encouraged him to go on one more exploratory mission together, where they traveled further than ever before to check out a lava tube that had only ever had the most cursory robotic surveying. This turned out to be where they found a gold strike and helped Camille become a major figure in the rise of a reasonably self-sufficient lunar economy that brought her back to New Sudan some years later to start her own family. For Leonardo, the journey was only beginning as he won a spot on the upcoming colony mission to Ganymede, Jupiter's largest moon, but that's a tale for another day. So how likely is this all to happen? Well, the good news is that robotic exploration on the moon is getting easier every day, even with setbacks like landers tipping over on their sides, and that helps us with lava tubes, as NASA has often had an understandable reluctance to attempt to send a manned mission to one. Given all the risk and difficulties of even just a regular mission to Luna, adding in a spelunking journey exacerbates that quite a lot, but dropping a robot probe down into one is a lot more viable. The exploratory module for that might need to be nuclear powered, or perhaps a ground base with solar power and a transmitter could maintain a hardline physical connection to the probe, given that the low gravity makes it quite viable to use your power cord as your rope down one of those skylights too. Indeed, Asagumo, a spider probe that was to be Britain's first ever moon rover, was designed with lava tubes in mind, and unfortunately it was delayed due to COVID. If you're curious, the name I'm probably mispronouncing derives from a Japanese spider that brings good luck, which might be appropriate given that delay is why it wasn't on Peregrine, which ended up burning up in Earth's atmosphere just a few days before I wrote this script's first draft. Fun side note, I was in Pittsburgh to give a talk at the Carnegie Science Center the same week Peregrine was shipping out from Astrobotics Lab there, and my wife Sarah and I were the last two guests to get to see it. Space is neither kind nor forgiving, so we must always be relentless in its pursuit, and here's hoping their next launch later this year has better luck. I'm quite confident we'll see robots exploring those lava tubes inside a decade or two, though full exploration may truly require a human presence, and for all the endless delays, I think that human presence returning and staying on the moon is fast approaching, and with it, in time perhaps, people living in those lava tubes. There are safe places we could build settlements from which might hatch our wider dreams of space, but are they places people would want to live and raise a family? Let me know what you think in the comments on today's episode. We were talking about the difficulties of trying to raise a family on some outpost far from Earth today. Education is a pretty big part of that. As we head towards summer break for the school year, one of those challenges, whether as a student or a parent, is trying to make sure you don't lose any knowledge during the long break. The best way to learn is daily, and establishing a daily learning habit is one of the most important things you can do, both for personal and professional growth. That's where our friends at Brilliant can help. Brilliant helps you build real knowledge in minutes a day, with fun lessons you can do whenever you have time. Brilliant focuses on fun and interactive learning, where you learn by doing, with thousands of interactive lessons in science, math, data analysis, programming, and AI. From simple to complex, whatever your skill level, Brilliant customizes content to fit your needs and lets you start where you should and improve at your own pace. I've been using and recommending Brilliant for years. They are our show's longest running sponsor, and I have yet to hear a single complaint, but I have heard plenty of satisfied customers. And you can try everything Brilliant has to offer for free for a full 30 days. Visit brilliant.org/IsaacArthur or click on the link in the description. You'll also get 20% off an annual premium subscription. So next week we'll finish out the month of April with a pair of episodes looking at colonizing white dwarf star systems, bringing new life to those dead stars, and binary star systems, and their unique challenges with habitable zones and stability. After that, we'll start May up with a look at the Banks Orbital, also known as God's Bracelet, a megastructural space habitat hundreds of times larger than Earth that advanced civilizations might build as an alternative to terraforming planets. And speaking of advanced civilizations, the week after that on Thursday, May 9th, we'll look at the interdiction hypothesis of the Fermi paradox, which asks if civilizations out in the galaxy might leave large buffer zones between their empires, and ask if Earth might be inside one such empty buffer zone. If you'd like to get alerts when those and other episodes come out, make sure to hit the like, subscribe, and notification buttons. You can also help support the show on Patreon, and if you'd like to donate or help in other ways, you can see those options by visiting our website, isaacarthur.net. You can also catch all of SFIA's episodes early and ad-free on our streaming service, Nebula, along with hours of bonus content like Galactic Beacons at go.nebula.tv/isaacarthur. Thanks for watching, and have a great week.